This is going to be like an overview of what the server project is and does, and have a little time at the end for questions. So the OCP Server Project is one of the original projects and one of the most active projects. We're here to identify the key technologies and trends, focusing more on the server and the server hardware. I assume everyone has a good understanding of all the rest of the projects they're going to be presenting throughout the engineering tracks these 2 days. We'd want to definitely focus on foster a community of collaboration on the solutions, creating industry standards. We're not a standards body, but we do want to focus on industry standards and specifications so we can all get some common hardware and get everything that works together. The technical work is done in a number of sub-projects and working groups. So we do have currently 4 sub-projects, and we're getting a steady stream of requests in for additional sub-projects. So I think over the year we will see a couple of new sub-projects added. We don't have a lot of details on those yet because it's all just discussions, but look forward in the year to come that we will be adding some. The server group meets monthly, and then each of these sub-projects has their own meeting schedule. Some of them meet monthly, and some of them meet twice a month and have different work streams and inside their sub-projects that meet. So there are quite a few server project meetings in all the subgroups. On the server wiki page, there is a schedule that has all those projects. So you can kind of see where we meet in that Google Calendar on that. The sub-projects we have now, we'll have each sub-project come up for a few minutes and describe their activities. So for all the sub-project leads, be ready to come up, and we have a mic for you here. I thought the stage would be big enough to kind of have us all up here at the same time, but it's a smaller stage, so we'll kind of cycle you through. So first we have the OAI sub-project that is open architecture, like the GPUs. I'll let the sub-project leads come up and describe it better than I can. Then we have the HPC sub-project led by Alan Cantle that is working on our high-performance computing, trying to get some standardization there. We have our NIC 3.0 sub-project. Sometimes we call it MES project, but the 3.0 version isn't actually a MES anymore, so we've kind of gone away from that nomenclature, led by Damien. Our ODSA sub-project led by Bappy. And our newest isn't a sub-project yet. We're hoping it will be soon. The DC-MHS has gotten a lot of exposure this year. So we have a lot of different sub tracks on the DC-MHS. Why don't we start going through the sub-projects? Song and Ahmed, if you want to come up. I can't really see in the audience with the lights against me. Hopefully they are out here. Looks like it's pretty early in the morning.
Yeah, the OAI project, the Open Accelerated Infrastructure, started right after OAM, the Open Accelerated Module, was contributed to OCP. Immediately after a module was defined, it was clear that we also needed to have a system around that module defined. That's where the Open Accelerated Infrastructure started. It's been active for 2-3 years. They have produced 1.0 spec of UBB, that's the Universal Building Block, consisting of multiple OAMs. They have power distribution defined, a host interface board defined. Just recently, NVIDIA contributed a UBB with 8 GPUs on it. Specification 1.5 has been contributed already, and they're working on 2.0.
Oh, actually, I started on this page, and there we go. got some slide work here. So yeah, unfortunately, it doesn't look like Song and Ahmed have made it in here this morning. As Siamak said, we do have the high-speed system, power, cooling, and OAM tools as different work streams inside of OAI. Each of these work streams has their own separate meetings. So like I said, you can go to the wiki and see the meeting schedules for these different work streams. Next up, we have the HPC subproject with Alan. It's outlined quite a few times yesterday, and looks like he hasn't made it in either. So, either you want to talk on the HPC subproject, or?
You know better. They're very active. They started in different fronts. Nowadays, I believe, they're following software and requirements for HPC itself. There has been discussions on a particular module. They have picked up some ideas from the OAI. The module itself, they are defining different memory and accelerator interfaces to the module. They have been active in interconnect between the modules as well. A very dense collection of memory and accelerators on one module. I believe that's the one that they are working on right now.
Yep. Thank you, Siamak. Next up, we have the OCP NIC 3.0 with Damien.
This is very
wow. This is definitely should have sent out a reminder yesterday on the timing of this.
We should have started with DC-MHS. That's the active project now.
Well, all these projects do have a lot of activity, but had some communication there.
There are sessions later today as well on OAI and NIC 3. Both of them are good ingredients for a modular system. OAI is, in fact, a modular system. We have a OAM, and you have universal building block and interfaces to a host and interfaces outside. NIC 3 is a very good component that plugs into servers. And DC-MHS, in a minute, we will talk, that's a modular hardware system. All of these have some affinities. So throughout a couple of other sessions today, we will talk about overlaps and the way that these teams can work together.
Yeah. So the NIC 3.0 has obviously been out there a few years now and is getting very good adoption throughout the industry. So currently, the three things that they're working on is they're working on a TSFF thermal fixture to do some more enhanced thermal testing, and they're also working on a higher version of the card, a taller form factor. It's only a couple millimeters taller, but it makes a big difference in the thermals. So we're enabling the slightly taller module to get better thermals, because the NIC 3.0 is a thermally challenged form factor. They're also working on PCI Gen 5 SI fixtures to do the Gen 5 testing, and starting to look at next gen, what the OCP NIC 3.0 is going to look like for Gen 6, and how we can increase the bandwidth through the manageability through the RMII-based transport, trying to get it up to a higher speed, because it does very much limit the ability to do firmware upgrades and stuff through the management channel.
NIC 3 is at high level a generic form factor and interface definition on PCIe. So although the word NIC is in there, the module itself need not be only NIC. Any PCIe compliant chip can be on that and plug in that module form factor. It could work very well.
Yeah, a good point. And actually, out on the floor, you'll see several cards that are in the NIC 3.0 form factor that aren't NICs. So it is broadening beyond that.
And there are two form factors. A large form factor allows more power and larger mechanical envelope. People who are designing anything to PCIe or soon CXL can benefit from that module form factor as well.
Next up, we have ODSA with BAPI. All right.
Okay, yeah.
Give him room.
Yeah.
Yeah, couldn't come up. There you go. Thank you.
Okay, thanks. So my name is Bapi. We're a group working towards an open chiplet marketplace. That's sort of the end goal, the vision that sort of motivates our group. We're pretty active. We've got about 8 work streams with about 50 companies, and we do essentially everything to do with chiplets. There's sort of 3 broad ranges of activities. One is trying to define chiplet interfaces. For those who are new, the idea of a chiplet is instead of a single monolithic die inside one package, a collection of die together giving you some function. So we define interfaces between the chiplets. The second thing we do is we do reference implementations of test packages and prototype vehicles. And the third thing we do is workflows, business workflows for chiplets. How do you describe chiplets? How do 2 companies do business with chiplets, et cetera? You should be able to find out a lot more. I think we're in this room, right? 940.
Yes.
Server room. We have 2 sessions, one from 9:40 to around just before noon, and the second later this afternoon. We've released 2 interfaces. It's been a pretty big year. We've released 2 interface specifications, something called OpenHPI and a bunch of wires. We have about 10 companies implementing silicon, doing silicon implementations with a bunch of wires. And we have a panel this afternoon talking about their progress. We also have other layers of the stack. We've had several white papers released, one on workflow, one on how to do business. Earlier this year, I think last year, we organized the biggest ever workshop under the OCP's banner, 600 attendees on a business workshop. So, and this year we had a chiplets conference, the first sort of academic industry chiplets conference. So there's a bunch of activities. We'd love to have more people involved. You should be able to find everything off on our wiki. And that's about it. Thank you.
All right. Thank you, Bappy. Next up, we have Sean and Brian for the DC-MHS Workstream. Come on up.
Hi, everyone. My name is Brian Aspens. This is Sean Dubey. We're the work stream leads for DC-MHS. It stands for Data Center Modular Hardware System. We've been working with the industry. It's Intel, AMD, Google, Meta, Microsoft, Dell, and Hewlett-Packard. We have, in the server project, on the server project wiki, we've released 6 specifications. You can see them listed here. It's the first one is we call MFLW. It stands for Modular Full Width. It's a specification for servers that is typically used for 2 processors. Doesn't have to be processors. The specs leave the center of the host processor module undefined. What we try to do is define the perimeter, the interface between modules, so that you can innovate in the center. So the first form factor spec is FLW. The second one we have released, it's called MDNO. It stands for density optimized. It's your typical 1-socket processor. By the way, if you haven't seen these, you can go to the Intel booth in the Expo. We have examples of these 2 that we've designed. And so those are the 2 form factor specs. I suggest that you look at these 2 first. They kind of describe the center of the server. Then we have what we call base ingredient specs. So there's 4 of those today. The first one's called MCRPS. It's a power supply that we've partnered with. The 7 companies that I mentioned earlier have partnered to design. There's 12 volt. We're working on 48 volt variants. So that's MCRPS. That's available. This second one is called MXIO. It stands for Extensible I/O. What we try to do with this spec is describe the CXL, and we align to PCI SIG cabled internal cable specs. So you can go to PCI SIG. They talk about 1016, which is a CXL attached cable. So the XIO spec is talking about the high-speed link from the host processor module. The third spec we have is called MPESTI. It's a peripheral sideband tunneling interconnect spec. So think of it like a virtual wire, and again, we're trying to eliminate or reduce the number of sidebands in the XIO spec. We're trying to align to PCI SIG and drive that back into the 1016 spec from PCI SIG. But it's a virtual wire that functions to reduce the number of sideband. And then the last one is MPIC. It stands for Platform Infrastructure Connectivity. Yeah, there we go. Think of this one as like describes I like to think of it like the rest of the server. So when you have your control panel, when you have your USB, your boot device, it talks about how to put the PCIe cards in certain power states. So this one is kind of the catch-all, the infrastructure spec. You can find all 6 of these specs on the server wiki today. They're at a 1.0 state, which means that we are in the process of releasing them to the incubation committee right now. Sean, do you want to go over the last 2?
Yeah, so what's next? We've gotten to 1.0, now we're looking for continuing the journey. And going forward, we have both a breadth standpoint and a depth standpoint. So from a depth standpoint, we want to improve interoperability. How easy ultimately to take an HPM, a host processor module, and drop it into a platform that's never seen the CPU that's on there, the CPU architecture, and the system can figure it out and operate with it. Now getting there, there's a lot of intermediate steps. So compliance testing is one of the big ones. The MCRPS is an example with the power supply. We're looking at enabling a set of compliant tests so that we know that all of these power supplies are truly interoperable. Then we have design guides, design specs. We've even talked a little bit about having generic reference design, so completely agnostic to what the CPU is, but there's a design to start with to drop a CPU into an HPM. From a breadth standpoint, what we want to do is expand out the coverage that we have within the data center. So to begin with, we have OpenRack v3. That's also going to 1.0 and released. So we want to enhance the form factors that we have here to take full advantage of the additional width that we have with 21-inch racks. Also, along with OpenRack v3 is 48 volt up to 60 volt operation. So that's an architectural change that or enhancements that we're looking for the HPMs to allow routing high voltage DC through the HPM, both to power the HPM as well as to power peripherals. A really major one that we've started up that we initially wanted to do, but the scope was too much, and that is dealing with shared infrastructure. So designing HPMs or having form factors that are directly compatible with a multi-node or a shared infrastructure system. So this is where we take the HPMs that we have, enhance or define the connector set that interacts with the shared infrastructure, as well as define a lot of the other elements of what exactly a shared infrastructure has, doesn't have, and ultimately to get to interoperability. A collection of these things we're going to be talking about in more detail tomorrow. And then last on a breadth standpoint is getting to better interoperability with other sub-projects, other projects within OCP. Discussed earlier was OAI as an example. So we're looking at a variant of the full width form factor that's optimized for connectivity to GPUs. GPUs is just one example, but ultimately it's a solution that is very much catered to a high degree of I/O coming off of the HPM and interacting with other modules. And then last, we are looking to upgrade DC-MHS to an official sub-project. So that's something that we hope to accomplish here very soon. That also includes having a monthly public meeting for anybody in OCP to get engaged with us, to have the dialogue, and to help us with moving DC-MHS forward. And last, if there's any feedback, we do have an email reflector. It's dcmhs@opencompute, and that will go out to a collection of all the leadership within DC-MHS and all the representative companies. Thank you.
I just want to add, tomorrow there's almost a 50-minute talk on, it's around 10:20, I believe. That one's going to double click onto each of these work streams, so encourage you to attend that. And then I think at around 2 o'clock, there's a panel discussion that we're having. Sean, myself, Siamak's on it, Jean-Marie from HPE. So I encourage you to attend those.
Yep. One comment on the feedback, the 1.0 that's on the wiki is a 1.0 release candidate. So if you want to review that, do it quickly. There's not time for any major changes, but any minor changes or clarifications, if they get it quickly, they can get it into the 1.0 still, since it's still a release candidate, it hasn't gone to the incubation committee.
Yeah, I think the incubation committee gave us about 3 weeks before they locked down that spec. So if you do have any last minute requests or feedback, just email Sean or myself or anyone else.
Or send it to the reflector, it goes to the whole group. Yeah, use the reflector. All right, thank you, Sean and Brian. So that goes through all of our work streams. Has any other work stream leader come in since we went through and want to come up? I didn't see anyone come in, just want to check. All right. Call to action. So like I said before, all of our call details are on the call calendar. There's a link here to it. It's pretty easy to find from the OCP homepages. We have the main server wiki and a wiki for the 4 sub-projects. It's one of the benefits of a sub-project over the work stream that DC-MHS is. That, all those sub-projects have their own wiki, so they can have their own status and their own pre-release files and everything else they want to share. We also have a mailing list for each of the sub-projects as well as the main server project. So if you're not on the mailing list, there's a link to go join those. And we encourage everyone to get involved. That's all we have for the presentation, and we've got a few minutes for questions. So there's 2 mics right here if anyone comes up, anyone has any questions for us. Quiet crowd this morning. Come on, somebody. All right, Mark or Siamak, either of you have any other closing comments if we don't have any questions?
No comments now, but right after this session, we're going to talk about the contribution process that we within the server project follow. That we'll go a little bit deeper on how we do things at server project.
All right, well, that's it. Thank you, everyone, for attending, and we'll start the next session up in a few minutes.